Hi everyone. Today I want to talk about fractions. First of all, looking at number sets in mathematics, and then looking at how fractions come about as a result of those number sets and what they mean. First of all, let's look at some of the number sets we encounter when we enter the world of maths. Here are 4 sets of numbers that we'll be looking at briefly, the first 3 mainly. First of all, the naturals, then the integers, then the rationals, and then the reals. But we'll be particularly focusing on the naturals, the integers, and the rationals. So if we imagine a number line here, which stretches to infinity in both directions, then we can illustrate exactly what we mean when we look at these sets of numbers. First of all, if we start with the most obvious, 1, 2, 3, 4, 5, the counting numbers, these form a set themselves, which is known as the natural numbers. This set is pretty much the first set that anyone learns when studying mathematics, as we can use it to count whatever groups of objects we want. Next, consider what happens if we include 0 and we count in both directions, 1 minus 1, 2 minus 2, 3 minus 3, 4 minus 4, 5 minus 5. This way we're going to infinity in 2 directions rather than just 1. And also consider what happens if we have an equation like 3 minus 4. The answer to that, as we know, is minus 1, but minus 1 isn't an element of the set of natural numbers or counting numbers. So it's an equation like this which gives rise to the need for a greater set of numbers, which we call the integers. So now we can add this second set of numbers to the naturals, which we already have, and we can display them as follows. So we've been able to count now from 0, 1, 2, 3, 4, and so on, going to infinity in the positive direction, stepping 1 unit at a time, and also minus 1, minus 2, minus 3, going to negative infinity, stepping 1 unit at a time. But now, what we want to examine is what or how can we give a name to numbers which fall in between these stepping stones? So if we blow up the number line as such, what if I decided to pick 3 points, such as this one here, or this one close to minus 1, or this one close to 2? What values do these numbers have, and how can I express them in some mathematical way? Well, here's an idea. Suppose we take the interval from 0 to 1 and we subdivide it into 10 subintervals, and I pick this point here. Well, from 0, how far is it? It happens to be 8 subintervals. Out of how many subintervals all the way to 1? 10. So, how can I describe this? As 8 over 10. So it's 8 parts present out of 10 parts total. This gives rise to the way that we enumerate fractions. So, we can now add a third set of numbers to the 2 previous sets we have. And this one's a little more sophisticated in its representation. So we call this the rationals, symbolized by Q. And the expression we give is P over Q, where Q is an element of the naturals, that is 1, 2, 3, etc. And P is an element of the integers. So 0, plus minus 1, plus minus 2, plus minus 3, etc. And that is essentially the representation of a fraction. So let's have a look at an example. So we saw before we had 8 over 10, but now we have 3 over 4. So what does that mean? If I draw a circle it means I divide it into 4 and I have 3 parts present with a 4th part not present, so I get 3/4 of a circle. Okay, so let's have a look at the parts of a fraction. The top is called the numerator and the bottom is called the denominator. Okay, let's have a look at another simple example. Suppose we take the fraction 1/2, 1/2. It means 1 part present out of a total of 2 parts, which can be expressed as half a circle or half a rectangle. And in this case, the numerator is 1 and the denominator is 2. Let's have a look at another example. Here we have 5/8, 5/8, which means 5 parts present out of a total of 8, which as a circle would give us that much, or as a rectangle, if we divide it into 8 parts, would give us the 5 black parts we can see. And again, with 5/8, the numerator is the 5 and the denominator is the 8. Okay, so if we are to look at a table of fractions here, if we take a look at the interval between 0 and 1, the top line of this display shows, as it's labelled, 1 whole, which is the entire part between any 2 consecutive counting numbers. The second line down, in lighter pink, shows when we divide into halves, 1/2. As you can see, there are 2 parts, and each one of those is 1 part out of a total of 2. And then below that, in light purple, we have thirds. So we've broken that entire interval into 3 parts, and each one of those is 1 part out of a total of 3, hence 1/3, and so on for quarters, and so on for fifths, and sixths, and eighths, and tenths, and twelfths. Now, one thing to note is that when we get a larger denominator, if the numerator stays the same, the fraction is getting smaller and smaller overall, even though one of those numbers is getting bigger, because it happens to be the denominator, the lower number. That means that the overall quantity is getting smaller. So, if we compare, for example, 1/2 to, say, 1/6, so I'm looking at the second to top line in light pink, and then I'm looking at the 6th line in light green, you can see that 3 of 1/6 makes up 1/2. Take a look at the fraction on the left-hand side. 1/1, 1/2, 1/3, 1/4, 1/5, 1/6, 1/7, 1/8, 1/9, 1/10, 1/11, 1/12. Something interesting to note here is that as the denominator gets progressively bigger relative to the numerator, the overall quantity gets smaller. Now this time, let's concentrate on the right-hand side, the rectangle, to see what proportion of the rectangle the fraction represents. So now, looking at the rectangle on the right-hand side, as we start this, we can see that we have the whole of the rectangle, half of the rectangle, third of the rectangle, quarter of the rectangle, a fifth of the rectangle, and the black strips get progressively thinner as the denominator gets bigger. Just to emphasize this point, we'll take large denominators now. So we'll start with 1/20, and then 1/50, then 1/100, then 1/1000. And we can see at the point of 1/1000 that we end up with having what essentially looks like an empty rectangle, because the fraction is so small. This is what happens once the denominator blows up. Here's another way of looking at this visually. If you imagine the following fraction on the left here, where the denominator gets bigger and bigger and bigger, the quantity on the right gets smaller and smaller and smaller. This represents the size of the denominator relative to the numerator. If there's a very big difference, then the quantity is very small. Okay, that's where we'll stop. In the next video, we'll have a look at operations on fractions. So what it means, or how we go about adding and subtracting, which are possibly the most important operations and perhaps the most difficult when it comes to fractions. Hopefully this video gives you a clear idea of what a fractional representation means, of how we generate fractions, and what kind of quantity they represent. If you look at a corresponding division of a circle or a rectangle into fractional parts. Thanks guys, and if this was helpful, feel free to like and subscribe, and I'll be trying to regularly create more content over the coming months.